Okay, so this is the second part of the vector day 1. So that at this point they're asking us to add these two vectors. Oh, well, in the first one they're asking us to add. So I need the vector 3, 2. So remember that goes 3 units in the x direction and 2 units in the y direction. Also notice that all of these problems, I just gave you a grid and I didn't give you an origin. So it doesn't matter where you start your vector. Your vector 3, 2 is going to look something like this, but it's not nailed down. It's going a particular direction, but it could start anywhere we want it to. So I'm going to say, okay, so let's say it starts here, and then I go 1, 2, 3, up 1, 2. So here's that vector A. And now I need to add vector B. I like to think about this as, okay, I started at home, I went to Starbucks, and then from Starbucks I came to school. Okay, or whatever. I didn't do that because I'd have to wake up earlier. But okay, so here's a vector B means we're going -1 in the x direction and +4. 1, 2, 3, 4. Did I count that correctly? 1, 2, 3, 4. There we go. And this is vector B. So when I add these, I'm starting at A, I get to this point, and then I add B, and I get up here. And the resultant is the vector that I have, this dotted vector that comes here. And I should have labeled A down here. But this vector right here is A plus B. Okay, if you notice, it's really hard to see, but if I come, this vector, I went over 1, 2, and up 1, 2, 3, 4, 5, 6. This is the vector 2, 6. Well, look at this. If I take 3 and I add -1, I get 2. If I take 2 and add 4, I get 6. So I can do this geometrically down here, or algebraically, or with the numbers up here to get that same answer. So it's not a bad idea to go back and double check and see that you got working through the numbers here. That's always easier. Does that match what you did down here? Okay, the next one is this -3a. Well, so if vector A is over 1, 2, 3, and up 1, 2, if this is vector A, then what happens here is -A means it's going to go in the opposite direction. So -A, when I start here and go 1, 2, 3, 1, 2, this would be vector -A. Well, now what they're saying is we need 3 of these. So start somewhere, it doesn't matter where, and you go 1, 2, 3, down 1, 2. Here's the first -A. 1, 2, 3, 1, 2. Here's the second -A. And then 1, 2, 3, 1, 2. This, and you wouldn't have to write these extra sets of arrows. I just wanted you to see what was happening. This is -3a. Okay, the next one, we're going to kind of put these two ideas together. We have 2a. So we start somewhere. I don't know where we want to start. Start here. 1, 2, 3, 1, 2 is A. 1, 2, 3, 1, 2. Here's the second A. There's 2A. But now with B, I don't want to go in the positive direction of B. I want to go in the negative direction. So I'm going to go the opposite. Instead of back 1, I'm going to go right 1 and then down 4. 1, 2, 3, 4. And so this right here, if I draw the arrow this way, then I need to label this -B. This is 2a and -b. And here's my resultant. Typically, we dot the resultant. Oh, I forgot. We went -9 and -6. So this is the vector -9, -6. Sure enough, if I come back to here and multiply by -3, I get -9 over -6. This is 1, 2, 3, 4, 5, 6, 7. I've gone 7 in the x direction and 0 in the y. If you come back up here, 2 times 3, 2, minus -1, 4, sorry. This would be like saying vector 6, 4 plus vector 1, -4, and sure enough, that equals 7, 0. Okay, I could have also drawn it this way and said, okay, I've got 2a going this way, and then a net b comes this way. And so this, if I start here and then I do -B, that's going to end up right here. So you'll see what I'm describing when I get down here with this one. So the first one, find a single vector that is equal to, I'm not going to write on the paper because it'll get too junky. I'm going to write on the paper for the tricky ones. So this is saying SI, so I start here and go here. So I should draw my little arrow like that. And then I add IB and I go to here. And then I add BR and I get to here. And so what I've done is I've started at S and I've made it to R. So this is the vector SR is its resultant. Now, IB minus RB. Well, IB goes this way. I want to say, you know what, let me just go straight to the difficult one. This one is BR, goes this way, plus RO. Can you see all of it? Yes. Okay, plus RO is going here. It starts at R and ends at O. And then here's CO. That means I start at C and I go to O, and I'm coming like this. And then KC means I start at K and I go to C. And so I'm going something like this. So what they're saying is they say, okay, go the direction of BR, go the direction of R to O, do the opposite. So instead of going CO to come this way, which is going to put me at point C, and then do the opposite of KC. So now turn around and go this other way. And so what I have done is I have started here and I end here. And so my resultant is the vector BK. So looking at this, I could say, okay, BR plus RO. Well, negative CO is the same thing as saying vector OC. Negative KC is the same thing as saying vector CK. Notice, hello, Mr. Brock. Okay, so notice that we have from B to R, R to O, O to C, C to K, and we ended up with BK, which is what we had here. I'm going to try and do this other one in blue. This is, I need new, I'm ready to get back in my classroom. I want construction to end because all of my pens are dying and the good ones are packed away. Okay, it's fine, it's fine. IB minus RB, so this is RB going this way. So if I do IB minus RB, that means I've started at I and ended at R. Oh, maybe that should have been dotted, whatever. Okay, so far so good. I'll keep going. We'll get to this point and then I'll stop and make another video. On this one, they say make at least 3 vector equations. So what I might think about here is that I could start somewhere. Let's say I want to start here and end here. Well, one way, okay, so what I have, oh, you know what, let me name these things. A, B, C, D, E, F, G is what I should have done to begin with. I'm sorry. Okay, so if I start at this point here, then I go in the direction of A, and then I have to do a negative B, and then I do a positive C, and that would be equal to, well, a negative G. I have to go that negative direction plus F plus E minus D, and now I have gotten to where I ended. Okay, let me do one more. It said 3, but I don't feel like it. Let's say we start here and end here. I don't know. I'm just making something up. So one way is to say, okay, this is vector G plus vector A minus vector B. I have to go the opposite direction, minus B, plus C, and then plus D. That started here and ended here, and that's going to be equal to F plus E. Okay, so come back for more. We'll talk about this one, and we'll see how far I get before lunch.